everybody's talking about AI, using the word autonomy. Can you explain basically how you're filling that gap then with what you're creating there at Exyn?
Sure. Yeah. So we were thinking about our technology early on, and again, how to really be successful with some of the technology the innovations we were leveraging from the Grasp Lab at Penn, and to work with the initial team that we had. And one of the kind of key realizations, and this was particularly true at the time in 2015, 2016, was that a lot of the drone operations at the time were what we like to call automated. So you might have a GPS automated flight where the system would fly from waypoint to waypoint, but you're in open sky. There's really no ability to avoid obstacles, or definitely not moving obstacles. And at this point, you're also relying on GPS or other forms of infrastructure. So what we saw was what we classified as true autonomy here, where it would be completely infrastructure free, and it would really start to act like an autonomous system that you and I would expect. So infrastructure free, we're talking about we were bringing forth technology that did not require GPS to navigate, did not require communications linked to the operator. So in other words, once our system was tasked with a mission, that it could lose connection to the operator and can complete the mission, or some other systems use prior maps to collect, and they'll use those to localize against. We were setting out to do something that was completely infrastructure free in all of those regards. And then looking at okay, well, if we can do this, where can this really be useful? And some great work from the initial kind of business development team. In retrospect, it just when we ended up in the mining space, it was just such a perfect fit. So what we're talking about here is in underground mining, the logistics teams, the surveying teams, they need to know if they blast an area, they create a new cavity, they need to understand the specifics about what was done. So they need to know how much material has been extracted. Was the blast successful? Is it an underblast or an overblast? I won't pretend to be an expert on the specific details of how they're using the information, but understand enough to be able to help out. So in this world, the only way that they could get this information was that they were literally sticking a laser scanner on a pole near where there had just been an explosion, right? So not the safest of applications.
Not by any means, no.
Yes. So sticking a laser scanner on a pole into the cavity to get a map. And the realization was, okay, well, we can use this true autonomy to actually get a laser scanner into that void, see around all the corners that you wouldn't be able to see with a single perspective from the laser on a stick, and come back to the operators. And now we're getting them more information than they've ever had before. We're able to get them further away from the danger area, right? And allow these operations to really be more efficient and more safe. So that was the kind of perfect initial fit. The product that was used there is very different than what we just showed in the video, and we'll talk a little bit more about the evolution for sure. But that was the real original problem statement, and that was our first and still to date our kind of largest successful use case.